Hello, this is Emmanuel, and in today's video, we'll be talking about radiation heat transfer and Stefan-Boltzmann's law. Please subscribe to my channel in order to get a notification whenever I upload a video like this. So first of all, what is radiation? Radiation is the energy emitted by matter in the form of electromagnetic waves as a result of the changes in the electronic configuration of the atoms or molecules. Radiation heat transfer occurs more efficiently in a vacuum. So radiation is more efficiently done in space, but the space should be a vacuum. So we move to the governing law of radiation heat transfer, which is the Stefan-Boltzmann's law. So according to this law, a surface that emits the maximum amount of radiant energy is called an ideal black body. An ideal black body. And we also have to know emissive power. Emissive power. This is the rate at which energy is released or emitted from a surface per unit area of that surface. The emissive power of a black body is given to be this. So this symbol over here is the Stefan-Boltzmann's constant, and Ts raised to the power 4. Ts is the absolute temperature of the surface in Kelvin. So you should always take notice that the temperature over here should not be in degrees, but should be in Kelvin. And also the Stefan-Boltzmann's constant is given to be 5.67 times 10 raised to the power -8. So the emissive power of a raw surface is less than that of a black body at the same temperature. So if you take a raw body and you take a black body, always at the same temperature, always the raw surface emissive power will be lesser than that of the black body. And the emissive power of a raw surface is given to be this constant over here is emissivity, and this one is the Stefan-Boltzmann's constant, and the Ts is the absolute temperature of the surface in Kelvin. So what is emissivity? This is the radiant property of the surface, which provides a measure of how a surface emits radiant energy relative to that of a black body. Its value ranges from 0 to 1. And also we have to know what is irradiation, which is denoted as capital G. This is the radiation which is incident on a surface from its surrounding, which may originate from special sources such as the sun or from other surfaces to which the surface of interest is exposed to. So this can be an illustration of what we are talking about. So this will be the small surface with the temperature Ts, and this is the large surface with the temperature TSUR. So this irradiation can be absorbed, reflected, and transmitted by the surface. So when this radiation is from the source to the surface, when it reaches the surface, three things can occur. It's either it's being transmitted or absorbed or reflected by the surface. So in total, irradiation is equal to irradiation absorbed plus irradiation reflected plus irradiation transmitted. So this is the constants introduced by the individual irradiation. But this alpha, this rho, then tau should always be equal to 1. So when the rho is equal to 1, the body is said to be an absolute white body. But when the alpha is equal to 1, the body is a black body. And also when the tau is equal to 1, the body is a totally transparent body. So we have a special case. The special case is when the alpha and the rho is equal to 1. This means that automatically tau is equal to 0, and this is an opaque body. So we'll come to the special case of radiation. So in most questions, this is the formula, or this is the case that we use. So this is the case that frequently occurs, which involves radiation exchange between a small surface at Ts and a much larger isothermal surface that completely surrounds the smaller one. The surrounding could be, for example, the walls of a room or a furnace whose temperature TSUR differs from that of the enclosed surface. and the irradiation from the surroundings may be approximated by the emission from a black body at temperature TSUR, in which is given as this. So in this special case, the irradiation is given to be G equals Stefan-Boltzmann's constant multiplied by TSUR raised to the power 4. T is the temperature. So the irradiation is taken to be that of a black body. That's why this formula is given. What is a gray surface? A gray surface is a surface whose absorptivity is equal to its emissivity. So in this special case, the net rate radiation heat transfer from the surface expressed per unit surface area at that surface is given by this formula. So this is the main formula for this case. Sometimes it's been written as this: Q dot is the heat transfer rate, and HR is the radiative constant or coefficient, and A is the surface area, and TS is the temperature of the smaller surface, and TSUR is the temperature of the larger surface. Thank you very much for watching this video. In the next video, we'll be talking about the conservation of energy requirements and stable and unstable systems.